Welcome back. So we've got a project that I'm starting. It's residence. I think it's going to be heating only. I just made a station and that's all I've done. There's no logic in there. There's just my standard date and time that I use. I've got to do the inputs and outputs. I've got to do the drivers, add the modules to it. That's basically it, and then of course I've got to do all the graphics. So I've just took a standard palette that I use, and all this lot's got to be changed. So all this lot is rubbish now, but I'll leave it there at the moment. And my top nav, I did name it, but I put a plus at the end of it for some unknown reason. And we're going to start doing this. So let's read through the description of operation. Bring that across from the other screen. Mainly the first bit's just all about the panels. 2 MCCP panels. MCCP1 located, the spelt boiler wrong, but located in the boiler room. MCP2 would be located within block C, whatever that is. The panel switches, safety circuits, normal fire alarm, gas detection, alarm monitoring, plant user display. The control panel is a touch screen, so we were using a touch screen there. And time channels, just one time channel, LTHW on 24/7. Boilers, using the return temperature. The boilers will be secretly enabled via the common CHP return temperature. So it looks like we've got a CHP there to maintain the required minimum temperature of 60 degrees. Lagging off the lead boiler will initiate standby boiler. The secrets will be rotated weekly, so we've got weekly rotation. Normal common fault. The boiler common return temperature falls below 10. BMS adjustable. Then the boilers and duty pumps are started. Yeah, that's just frost protection really. 60 off. Each boiler has its own shunt pump, hardware interlocks, heating, fire alarm, high flow, and no shunt pump flow. Well, okay. Yeah, no shunt pump flow. We don't put the boilers on. So it's permanently enabled. Each boiler to be controlled on receipt of the signal from the automatic controls, using the temperature sensors to maintain the required flow. Yeah, normal one of the mill. Isolation primary pumps on all operation boilers. Yes, yes, yes. Run on for 10 minutes. Adjustable. Sequence control. Ensure burner start boiler similar interlock with the burner pump. Run of the mill, like I keep saying. Pressurization. Booster cold water service. Frost protection. Should the outside air fall below 4, sets will be enabled. Measure outside rises 5. Controls revert back to normal. Should the outside air temperature continue to fall below 0, then boilers and LTH pumps temperature. So basically that bit up there that it mentioned 10 degrees, that must be on not frost protection, that's just normal time schedule. If it goes below 10 degrees then started until return temperature rises to 60, if it ever falls below 10. Well, it's only going to fall below 10 because 10 is a very low number. Even standing water is not going to be 10 in an LTHW pipework. Standing water is going to be 17, 18 degrees. So I think that line is a bit rubbish, because if it's at below 10 then you've got no boilers, end of story, or you've got no circulation pumps, and I don't think it'll ever get below 10, the water in the pipework. So that is a stupid figure, but what we can do is we can make it adjustable, and I would put it from 10 to say 30 so that it can be adjusted, and we can also make the 60 adjustable as well if we need to. So that's that. Right, let's have a look at some more here. So let's look at the MCP1 panel. So what have we got here? Come on. Is it trying to catch up with me or what? Why aren't you showing? Oh, here we go. Should scroll down now. He says, no, it's not. Let's look at MCP2 panel. Let's see what happens there. That's not very good, is it? We can look at, let's turn this around. So what have we got here? We've got 3 boilers, gas detection panel, fire alarm panel linked to the gas detection, carbon monoxide detector, gas detector, normal one of the mill, gas valve. 3 boilers, each one's got its own shunt pump, and we've got a header there, a header there, boiler's going to a header, and coming off the header we've got landlord circuit F, secondary DH flow, amenity circuit F, secondary DH flow. So I'm just looking, pressurization units, dosing pots, buffer vessel, temperature sensors on them, interlinked, reversible direction of flow. Landlord circuit, flow and return, flowing at 70, returning at 40. Going through there, that's my boiler return. So we've got a return header and we've got a flow header. 20 to 40 returning back to the boilers, coming back out again at 70. Pipe work sizes, and single pumps, not twin pumps. Okay, what we got here? Mechanical circuits. Let me just bring that across. And it loads up. Boiler, 3 boilers, 3 pumps, another 2 more pumps there. Spirotech gas solenoid valve. So they're just our amperages. We've got an overdoor heater there, 3 of them. A refuse extract fan, AHU3, that's a supply to MVHR. Mechanical ventilation heat recovery, supply fan, AHU1, AHU2. It looks like we're just enabling them. Water booster set, but they've been fed separately by the company. This is from our panel, and the red is the bit that's been added extra in, gas solenoid and everything. Right, so we've got that, and I've got another one that I can open up. What's this about? Design and approvals. I don't think I'm worried about any of that. That's not really anything to do with me. Copper fittings, what flat fittings to use. Yeah, I don't think I'm worried about that. that's nice to keep. We may put that onto a drawing. Let's just minimize that out a little bit. We may use that as a background, I don't know yet. But while I've got it open, I think I'll go down another one. And if I can snapshot that, snipping tool, and let's just take that like so, and let's save that. Mech drawing. Okay. Close that down. Let's just move that across to there. Let's just move that down. Let's just go and get that mech drawing wherever I saved it. It's on my other computer, on my other screen. That one there. Let's just quickly open that with just normal paint, Windows Paint would do. And let's just take out that at the bottom. And that would do for me. File, save as. Save it as a PNG, and we'll save it as a JPEG as well. Save. Yes. File. Save as. JPEG. Save. And then the JPEG is 819. The PNG is 597 kilobytes. So it's a PNG that we're going to use, the lowest. Let's go to our software, M4 Workplace, and file system, drive C, users, Office, downloads, modified date, and then we said we're going to go with the ping. Copy that and put that into our images folder. And then what we can do with our home page there, we can take out all this rubbish here. Take all that out. New picture. Click on that. And then click on image. File system, images, mech drawing. Okay, okay. And we can have that as my front page. Take out this rubbish here at the moment. Make that up to there. Reorder to bottom. Just, I don't know yet, but anyway, we can have that there, and then we can populate it. But we'll probably do a graphic just for the main one. We'll do graphic. All these are going to be wrong, so we going to have a miscellaneous, I think. We could have adjustments still. PDF files, I can put all the PDF files on there. Alarms, maintenance alarms. There's no anti-legionella. Well, there's a fan somewhere. Don't know about that yet. I'll probably put that as boilers and then do the boilers. And yeah, just draw it up ourselves. But first of all, I need to start on the points. Let's see whether these panels work again. These are they now working. Now they've all loaded. Let's do MCP panel 1. A bit slow. Okay. So we've got transformers 230 to 24. 230 to 24. One's feeding the ISMA controllers. The other one is the control side, i.e. field stuff going in and out. Fire alarm, we've got the gas detection system, which has a gas and enables a gas valve, does the CO2 detector, natural gas detector, pressure sensor, plant room, and thermal links across the boilers. Just 3 boilers there. BMS out, energizes relay 137. 137, once it's energized, is healthy. 137 goes across to that. That light goes out. We've got a degasser PO pressure unit, low pressure, degasser high pressure, and going to the pumps. That one, and that's going to the boilers. So it looks like it's hardwired good. Degasser pressurization unit was up there. Up here, PU01. Go down again. Differential degasser PU01. That one is my boilers, shunt pump and boiler 1. We're modulating the boiler 0 to 10. Lockout alarm, enabling the boiler there. External interlock on relay 325. This is a 325, which is your pump. So we're actually checking it all, making sure we get the pump flow before we actually enable the boilers. So we've got definitely a lot of hardwired protection. That's going to be the same for the other boiler 2. That's going to be the same for boiler 3. And what have we got here? Secondary pump set PO4 and PO5. Speed control, run, fault, and an enable. Probably gun frozen over, not the lower pumps. Okay. Next one. Now this is our baby. Did we have got some Santes there? Sante leak detection unit. Another Sante leak detection unit. Going to terminals, putting relays on. Low level, high level, low level, high level for the 2 buffer tanks. And also low and high for the cold water storage tanks. Then we've got booster sets, filtration, water conditioner. Again, they're just faults. Looks like they're closed on a fault. Just taking all this information in for when I'm doing my logic. Then we've got the gas detection panel. They've added a CO2, that's why it's in red. Wiring by others if required. So we've got one EPO only. Emergency stop button. kitchen supply fan, kitchen extract fan, differential switch across there. Okay, and in auto, digital output 7 there on the Mac 36 controller, and digital output 8 on the Mac 36 controller in auto mode. And then that relay R1028's got to be enabled, or whatever R1028 is. Package AHU. Oops. And we are enabling the AHU. Occupancy enabled. And that is a fault. So that's a fault. Puts a common fault light on, and that's an enable. 3 package AHUs. Extract fan, toilet. Block A bin store extract fan with differential switches. So we just know that we're not enabling them, they're on overtime, we just know that they are working. Now here's our babies. So we've got a ISMA B MGIP, so that's going to be for our RS485 and probably M-bus, yeah, M-bus there. So we've got M-bus meters, heat meters, AHU 1, 2, 3, blocks A and C and block B, and then they will go into the electrical metering board. We've got our Ethernet switch, and we've got a router in there for remote access, a touch screen, and I'm just looking at that, all the heat meter typical connections. Yeah, flow and return, and of course the heat meter will have its own internal flow sensor. So they're just temperature sensors. What else have we got? So we've got an ISMA B Mac 36, boilers, flow, return, secondary flow, secondary return, buffer vessel upper and lower, buffer vessel 2 upper and lower, section 1, section 2, storage tanks, north side, outside air, temperature sensor, reception, kitchen supply, kitchen space, package or BMS supply, overdoor heater, unit details to be confirmed, gas supply, pulsed. Okay, so we've got pulse coming in, so hopefully they're going into an input. If not, universal. Oh dear me, that's not going to work. They're not fast enough. I need to do a request for information now. Block A and B gas supply, gas meter, pulse going into universal input 16. They will work on the digital inputs, they are fast enough. So I think we need block A UPS common alarm moving across to UI 16 and block A and B gas supply putting in its place, swapping them two across. So I've got to do a request for information there now, why they think a UI 16 is going to be fast enough for a pulse, which is not. It's bullshit. So I've got to inform them of that. And then we've got 1 analog output and 2 for speed, but one of them is for the kitchen supply fan heating coil. So that'll be using a thyristor, I should imagine. Spare analogs there, and then the digital outputs are there. Boiler number 1, boiler number 2, boiler number 3, pump 4, 5, and enable supply fan for the kitchen and extract fan for the kitchen. That's 7 and 8. 5, 6, yeah, 7 and 8. Right, further down, digital inputs of an ISMA 8i unit they're using there. So that would have done all our pulses as well, of course. But we've got monitoring faults, kitchen, supply fan, extract fan, toilet extract fan, bin store, CF, okay, block A and block B. And then we've got a 4U, 4A. So the 4U's is going to be the close, run and open fault of smoke extract fan of block A and block B. And then we've got a boiler number 1 enable modulation, boiler number 3 modulation, and AHU 1 to 3 enable using an analog output. So I presume that's going to go to just some sort of relays, 10 volt relays. I don't know what they're doing there. I need to look at that. 506 and 363 wires. 506 and 363. And then that's the panel details. Right, I need to look at this 506. Let me put you on pause and let me have a quick look at that. I'm just going to send him an email. I'm just going to just highlight that and highlight that. Oh, let me send that email. Right, I've worked that one out. It was easy enough. So that's boiler 1. AO1 is boiler 1, AO2 is boiler 2, AO3 is boiler 3 modulation. AO4 on this unit is going to an RM 3.1, 506 and 363. So move that across and here it is. That's the unit RM31, and depending on the voltage we give it will operate or enable package unit AHU 1, 2 or 3 depending on that voltage. Now I don't need you to come across one of these before, but I will send you some info. I'll get some information now just to show you. Let me put you on pause. So here is the RM3 module, 3-stage relay control. Let's just click on that. I don't know where it's going to take us. See if we've got any details of it anywhere of voltages. So nothing there. Let me put you on pause again. So I was just looking at BMS parts, but they don't sell a 3-1, they only sell a 4-1, which is no good to me. Don't think they've got... Oh, yes they do. They do sell a 3-1. I'm sure I'll find information here because there are always data sheets normally with these. And here we go. 3 modules and staged or sequence. So 1.5 volts are all off, 4.25 are on relay 1, 6.75 relay 2, and 9 volts or 10 volts relay 3. and that's the way we want to be doing it, sequenced. So I'm sure the 123 on, but we'll be using the sequenced. We won't be using this, because this one 4.25 puts 1 on, then 6.75 puts 1 and 2 on, and then 9 volts puts all 3 on. Well, we want it individually. So 4.25 volts. So anything, because I'm going to have to send it a voltage to put AHU1 on, send it a voltage to put AHU2 on, and send it a voltage to put AHU3 on. Okay, so we know more about that now, of what voltage we need to send. So I would put, say, 5 volts on for AHU1, 7 volts on for AHU2, and 10 volts on, well, I could use 9, but 10 for AHU3. Right, we don't need that anymore. We don't need that. So we've looked at that one, so I'm happy with the drawings for that one. Now we're going to look at the other panel now and see what that's all about before we start designing. Just gives us a good insight of what it's trying to do. Fire alarm interface, that's normal, one of the mill, interlock. That is again Sante's leak detection points. So we've got Sante's leak detection, we've got 2 tanks there. Booster set, filtration, conditioner, spare drawing sheet we don't need, come on. Section 1, section 2, storage tanks, temperature sensors, block C, level 3, LTHW heating, differential pressure sensor. Right, that's differential pressure sensor, 0 to 10 volts DC, going into universal input 4, so that's going to be the top of the riser, isn't it? And we're going to use that for pump speeds, I presume. Fire alarm, water conditioner, and what's this? Block C, water meter, pulsed. We'll put them on the right ones this time. We've used high and low level there, fine. Faults, tank. So we've got some pulses there. And then we've got LTHW heating minimum bypass, analog output for a valve, spare drawing. Okay, so that's a smaller panel, but it looks like these, oh, it's got a Mach 36 controller, okay, just one Mach 36 in there doing that. So we've got to do software for 2 Mach 36s. There's no I/O on this one. So I will start with MCP01, which is the biggest one. And then I will do the second one. So it's got an ISMA BMGIP module, not using the M-bus at all, but taking some electrical meter readings on the RS485. Okay, and that's got a touchscreen and one Ethernet switch, and that Ethernet's going back to MCP01, so we can pull the data from that if we need it. Alright, well, I think we need to get started. I'm going to put you on pause and get everything ready to start doing this. Right, what I'm doing at the moment is I'm just put this quite large at 150 so I can see what the modules are. So I'm just going to go through this at the moment. Just move it back to my other screen. It's always good to have 2 screens when you're designing software. Duplicate that. That's module 2. Module 2. So we're going to have a a folder for our inputs and a folder for our outputs. Duplicate that. Module 3. Module 3. Duplicate that again. We're going to have a module 4 there. All inputs. And then after that, I'll just bring that back across for you. After that, we have got 3, 4, done that. Module 5 and module 6 is the 4U, 4A. Bring that across. So we've got a module 5. And then duplicate that. This time call it 4U, 4A. Module 6. So I'm just checking. Yeah, 4U, 4A, module 6. 4U, 4A, module 6. 4U, 4A, M6. So that's ready for our points coming in. And we'll go to our Modbus. In our drivers, COM1. And why is that slow? So I'm just looking across there because that's where the controller is that I've got online. There don't seem to be any issues. Sometime today we'll be fine. Let me put you on pause. I don't know what's going on with my machine, but anyway, let's go to the control library. ISMA. We could use that one. I think that's got now the new components in there. We're not using TCP, we're using RTU2 wire. I normally don't use this, to be honest with you. I don't want any of them. I want that. Take that across to there. And let's open up the wire sheet. Naturally it's not connected. And module 1, are they all there's no pulses or anything, is there? That's what I'm looking for. I don't want to make sure there's no pulses for module 1, otherwise I've got to bring in some more points. It's as slow as anything, my computer. Maybe I should shut down and restart again. Come on. Module 1. No, they are all inputs. Module 2 are also all inputs. Let's check the other modules while I'm here now. Module 3 are all inputs. Module 4 are all inputs. Module 5 are all inputs. Module 6 are all inputs for that. And then of course we've got the analog outputs. So we're all inputs, so we can leave that as it is. I'll just put a header in there. Copy. Paste. And we'll paste in there as well. Use wire sheet. We're going to duplicate this now. That would do. Duplicate. Yes. Duplicate. Yes. Duplicate. 6. Set module 6 is not A. Delete. 4U4A. For A number 6. Wire sheet. And the universal inputs on that are digital inputs, so we can leave them as they are. And then of course we've got boiler 1, boiler 2, boiler 3, and then we've got the AHUs, which we don't want that because we're not using them as digital outputs. So what we're going to do there is we delete them and we go to our points, analog outputs, and put them across to there. Just tidy it up a little bit and take out in 16. And our software, we are going to be using 0 to 100. So we need these are set at the moment as 0 to 10. Don't want to do that. Use pin slots. The cat was jumping up and it just distracted me. So we can change these now to default scale. So that's 0 to 10. So that's 0 to 100. Not to 100. Not to 100. So 100% will give us 10 volts. Not to 100 on them. And that AL4 is going to be different voltages depending on the AHUs. So that's that bit done. So now let's have a look at the ISMA stuff. So they're my standard ISMA modules, all named completely wrong. So let's just delete all that because that was all on the other, and we'll start again as a fresh. So let's go to the ISMA, which is up here. ISMA. Mac 36 ISMA UI1. So let's click on that. New. And UI 1, 2, 3, 4 are temperature sensors. 5, 6, 7 and 8 in this case are just switches. Are they? No, they're all temperature sensors. Buffer vessels, upper and lower temperature sensors for 5, 6, 7. Sorry, let me just show you. Come on. Temperature sensors. All temperature sensors. UI1 to UI8. Put 8 of them in first. I'm not going to name them because I'm going to name them on the other, so I'm going to leave this as it is. But I need to select all them, and I need to select them as 10K3A1, and we'll leave everything else as it is. So that's them. Next one down on the sheet. 9, 10, 11 and 12 are temperature sensors. 13 and 14 are temperature sensors. So new, universal, 1, 2, 3, 4, 5, 6. And they are 10K3A1s. So that's 4. 1, 2, 3, 4, 5, 6. Another 2. This is where we've got the overdoor heater. So UI15 is just a digital. So new, digital input is UI15, and UI16 is also digital input. I'm going to do it like, I know it's not going to work, but so universal input, and so I want 15 and 16, but we know that 16 is the gas one, and I've done an email to tell them that that won't work, but I'm going to do it as per the drawings at the moment. Otherwise I don't want to confuse things until they give me the go ahead and they swap it around on the drawings. So 2 more universal inputs, but this time these 2 are going to be digital. 14 and 15. And then we've got digital inputs, which are pulses, and we've got using all 4 of them. So new digital inputs, 4 of them. Okay, and we haven't got to change anything there. That's wrong. Or is it? We need to put that. No, it should still accept it. It should still accept it. But normally we put counters in there for pulses. But I don't think we have anything here for that. Mix 38. You're not, they got a Mix 38 as a Mac. Ismo IO and local device, not that. Network there. Them. They've got to be them. Let's take that out. 1, 2, 3 and 4. So let's delete them. And all of them, oh no, 2 of them are just normal. So, but 1 and 2 are actually the pulse ones. And then we've got normal inputs. That's actually going to be not that. That's going to be actually address 3. Let's delete that. Let's enable them too. Do one at a time. Enable, true. enable, true, new, 2 digital inputs. Let's see if they automatically, no they don't. Okay, well I know that's 3 and I know that's 4. So that's meters, water meter and a water meter, AB1 and AB2, and that's common alarm, but that will be changed. Down to the next sheet. So now analog outputs, so that's new, and let's do the 4, which is 4 analog outputs. We're using 1, 2 and speed control is 1, speed control for pump 5 is 2, and kitchen supply fan heating coil is 3, and 4 is spare. 5, 6, 7 and 8 are all spares. So let's just bring them all in. Analog outputs. Oh, there's a digital input counter. Let's change that. Let's just do that from the sheet rather than the palette. New digital input counter. 2 of them. Enable both of them. I think it's still going to give me the same. Let's say 1, 2, and then new digital inputs. 2 of them. Yeah, it still did 1, 2. Okay, I thought it might be a bit clever and it would know that I've already put them in, but obviously not. So we're back to where we was before. Let's just rename that to 3 and rename that to 4 and put that to 2 and put that to 1. And really we should do all them 1, 2, 3, 4. So that's 16. Let me put you on pause and let me just do that. Okay, that's what name now 1 to 16. 1, 2, 3, 4. As per the drawings, which we know we are wrong with 16. There's no way that's going to work as a counter. We've already established that. And they're going to be swapping some around once I get the revised drawings or the go ahead. So now we want the analog outputs, which we've got 8 in total. New analog outputs, 8 of them. Okay, okay, and I'm going to rename them as well. I'll start at that because it's easier to, I don't have to start messing around with numbers. It won't say it's duplicated. 7, 6, I've got a cat above me that looks like it's going to jump on me at any time. 5, the office cat, Baggy. 3, 2, I bet he thinks, you idiot, you're talking to yourself. 1. And then we have got some digital outputs, and I think they're all being used. So we've got 1 to 8 there, and then the next page down, then we're on the modules. Now, new digital outputs, 8, okay. before we put them on there. Six, 7, 8. 8 digital outputs. So that's our I/O done on there. Let's go into our Modbus and let's just change these. So that's going to be 2, that's going to be 3, that's going to be 4, that's going to be 5, and that's going to be address 6. 1, 2, 3, 4, 5, 6. Now I also notice there's an ISMA MG as well on this job. It showed it me right at the beginning. Here we go on that page. ISMA MG IP. Right, I need to add in an ISMA MG. Let me put you on pause a minute. Alright, ISMA MG, where are you, ISMA MG? I think you are going to be TCP, because you will be, and gateway. There we go, ISMA MG. So let's put that. We need to set up Modbus TCP IP network. Presume I haven't got the driver on, he says. I'm not too sure whether I have or not. Drivers, new, Modbus. Where are you? There we go. Modbus TCP IP network. No, I haven't got the driver on. Platform into software manager. This is gonna, I may not boot up. Come on. Analyzing installables. I'll put you on pause while it does that. Right. Modbus. That's the one. Should put the WB in as well. Install. Yes, it does. Commit. Okay. No reboot required. Drivers. New. Modbus. TCP network. Okay. Okay. And then ISMA. Drop it into there. Illegal parent. Modbus TCP. Oh, gateway device. Aha. I can actually use theirs, can't I? He says. Get rid of that. Delete. Should have known, it shows it there anyway, so I should have known. Now it's dropped it in there. I've actually got a Modbus one on my test rack, but I haven't got it connected, so it should fail eventually. Should we bring the settings across? Why not? bring that across to there. See what it, if that's alright. That's the wrong place to drop it. That's the right place to drop it. Okay, we know it's offline. Right, we'll leave that as it is because we can't do anything with that now until we're on site and discovering the network for the M-bus and the Modbus. So we'll leave that as it is. BACnet, I don't think we are using at all, but I'll leave BACnet on. Let's see what this is. IP port. Using that IP port there. And then that one, views AX. The IP address of the Modbus gateway, I think it's going to be 192.168.1.123, I think, which is the same IP address at the moment of the controller, except I'm using 0123 at the moment. Yes, you will be down. Okay, we can leave that as it is, because that's nothing's going to happen there until we're on site. 502 port, which is a Modbus port, which is right. So now we need to do, let's have a quick look at that, because that will have a load of rubbish in there. Views, wire sheet, and that's got all about that in there, which we're not using the mix at all. And we need to delete them because they're all wrong as well. So we've done all the inputs and outputs on the driver's side. So ISMA's all done there, and Modbus all done there with all the points. So now we're going to start putting them into our inputs and outputs. So we'll start on the inputs first. Go back to the sheet when I find it on my other screen. So page 16, UI1, boilers common flow, new reactable, UI1, boilers common flow. That's going to be a temperature. No, where are you? Get there. Temperature, drive C, drive C, Celsius. Okay, save. While we're at it, we will put a history on that. Histories and extensions, and we'll do a numeric change of value, and we'll also do a alarm on that, an alarm, extensions, out of range. The out of range alarm is going to go to critical alarms, and high limit anything above 110, low limit anything below -10, because boilers common flow. I can just put -50 there, and we can use it then for outside air as well. Just showing us that sensor faulty. Sensor faulty. Sensor faulty. Sensor faulty. Sensor healthy. Save that. That's our boiler's come and flow. Views, wire sheet, pin slots, take out 16, actions, set at 0. Boiler's come and flow done. Boiler's come and return. Duplicate. Return UI2. I don't need to put history on or anything because we just copied that one, all the alarms. Landlords, DH secondary flow. UI3. Landlords, district heating, I presume. Sec, flow. Duplicate. Sec, return. So that's 4. Return. And then we've got buffer vessel BVO1 upper and lower. Duplicate. UI5. Buffer vessel upper BVO1. Duplicate. UI6. Lower BVO1. You notice I did BVO1 right at the end, so I can just do that and duplicate, but I still got to go in and change the bloody UI number here. 7 and 8 is lower. 8 is lower. That's finished on that sheet. Next sheet down. UI9, section 1, CSW storage tank temperature sensors. Duplicate. UI9 is CWS storage tank section 1. Duplicate. 10 section 2. Outside air, next done. 11 OAT. OAT is not going to get to -50 or whatever, so we know we're going to be okay with the alarm there. Reception space temperature is 12. Reception. Space. So we can use that for the frost protection for the space. That's UI 12. UI 13, kitchen supply air. UI 14 kitchen space. UI 15, that's the overdoor heater fault. UI 15, overdoor heater. Well, there's three heaters as far as I was concerned. Unit details to be confirmed. Okay, overdoor heater fault. Right, I need to go on what they are telling me here on the drawings. I've got to follow the drawings, but there could probably be another couple of more faults put in at a later date, and that's going to be open is healthy, closed is fault. Save that. Let's put an alarm on that. Boolean change of state alarm. And fault. I could put overdoor heater, but I want to just keep it generic, healthy. Maintenance alarm is not critical overdoor heater fault. Well, I don't think it is anyway. Save that. That's okay. That's all okay. Should we put a history on there? We're going to get an alarm and we're going to get alarm histories. But why not? There's no harm in having histories, as long as it don't take up too much space on the station. The default's 500 points, so numeric change. Let's have a history on that. Really? Not numeric, Boolean change. It's me, I'm talking and not concentrating enough. Yes, 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 yes. And $500 records. We'll do the histories later. Do them all in one go. We don't need to just enable each individual one. And then the UI 16, which we know is not going to work. Go back. Is a gas supply. Now it is a digital input. It's not going to be, it should be a numeric value there, and I know it's not going to work, but I presume I've got to just do what I'm supposed to do. We just put a counter in there for them. I'll do what it's telling me to do, but I know it's going to go to a numeric writable eventually. I'll just do what drawings are telling me, but I know it's wrong. Post gas supply. It's called a GM1, gas meter 1. Waste of time, but it is what it is. Action set. Actions set as to false. I'm not even going to mess with that because I know it's wrong. So digital inputs, these won't be wrong. Let's just split that now. So half of 16 is 8. Bring them babies across to there. Now these are the right ones, so let's do a numeric for that. These are pulse ones now. So numeric writable, and it's DI1, and that is going to be a pulsed block AB MCWS supply. Just abbreviate block A underscore B. I don't want to use a forward slash because it gives us a lot of stupid characters. MCWS, that would do. Now that's going to be in meters cubed, I would have thought. Action set to 0, and that's going to be meters cubed. Meters cubed, meters cubed. Save. Put history on that. Numeric change of value. Drop in history on there. We'll do the history change though of 1 meters cubed, not 0.1 or whatever. The next one is exactly the same but for BCWS. Duplicate D2. BCWS. Block A and B. The next one is block A UPS common alarm. New. Numeric Boolean writable. I might as well take that over door heater. Duplicate. DI3. UPS. Because I've ended in a capital, I'll do a space. Common alarm. And it's block A and there's a block B. So let's do the UPS BLK A common alarm. Alarms when it's closed, so we can keep all that lot in there. We can keep that because it's generic. I could change fault to alarm. Let's just do that. And then we're going to copy that. Let's put that to a critical. And duplicate it again. UI4 UPS block B. So block B, yes it is. Common alarm. So that's our inputs done there on the Mac 36. So the next page down is that one, and there are analog outputs for the Mac 36, so let's just do them now. Let me just take these, delete, no I don't want to delete it, let's just take these down a minute, highlight that, reorder, take that and that, move them down to 8, take that and that, move them down to that, take that and that, move them down to that, mix 38 DIs. Okay, so very nicely spaced there. back to our outputs. Analog output, so we've got to be a numeric. And A1 is pump 04 speed control. Speed pump 04. Pin slots take out in 16. Action set to 0. We're going to be using 0 to 100%. Don't need the decimal place. And we'll put a history on it, numeric change of value. And that would do for us. Speed pump 4, but I'm not saying pump 4 speed control. Okay. Duplicate. Pump 5 speed control is A02. A01. A03 is kitchen supply fan heating coil. Kitch sup fan heat coil. A04 spares, all spares. Duplicate. A04 spare. Take out that. I'm not putting numeric histories on anything that's spare. Duplicate 5 spare. Duplicate 6 spare. Duplicate 7 spare. Duplicate 8 spare. Digitals. Boiler number 1, pump 1 enable. Numeric. Boolean. D01. Boiler number 1, pump 01. Boiler number 1, pump 01. In 10, take it out. Sorry about the dogs, if you can hear them. Enable. Disable. Okay, save. Go back out. Duplicate. DO2. Pump 2. Boiler number 2. Pump 2. Duplicate. 3. Boiler number 3. Pump 3. That's that. Output 4 is spare. Duplicate. DO4. Spare. Take out the... Oh, we didn't have anything on there. Right, let's just do that. Boolean change of value in there. Boolean change of value in there. And Boolean change of value in there. So we can monitor the boilers coming on and off. At what times, etc, etc, etc. DO4 we won't bother. DO5 is pump 4 enabled. Whatever pump 4 is, it doesn't tell me on the sheet. That's going to sheet 6. That's duplicate. DO5. DO5 is there. Take that out and it just pump 4. I'm going to put you on pause and find out what pump 4 and pump 5 doesn't tell me on that sheet. It is the secondary district heating circuit. Pump 4 and pump 5. Rename sec district heating pump 4. Duplicate 6 pump 5. Right, I need to go back to that drawing. So with DO5 and DO6, that's modules. That is universal input, so it's got to be that. Pump 4, pump 5, and then kitchen supply fan and kitchen extract fan is 7 and 8. Duplicate. Seven. Supply fan. Duplicate. 8. Kitchen extract fan. That's that. So the next page we're on modules, I think now. Yeah, input module 1 is my B8i. So that's all our outputs, and there's only there is a the last module is actually going to be before that one there. Copy, paste, and it is module 6. We're going to have some outputs on there, so let's just do them. I'm just going to that module 6. First output is boiler number 1 modulation. Duplicate. Modulation. Boiler number 1. Duplicate. Modulation boiler number 2. Duplicate. Modulation boiler number 3. And duplicate 4 is AHUs 1 to 3. Let's just rename that, and let's just put RM3 mod. So I know it's an RM3 module. I don't think we put any history on them, did we? We got history on that. Oh yeah, we have. Good. What are the histories set at? Now that is not going to be percentage, is it? Boiler 1 and 2 can, so let's just go back into our modules and that module and that module and our proxy. Zero point 0.01. Now this is a different, so that's going to be 0.1 because I'm doing 0 to 100. That's going to be 0.1 because I'm doing 0 to 100. That's going to be 0.1 because I'm doing 0 to 100 in speed or modulation. But that one is going to stay the same as it is. And we're going to put that to voltage. Electrical potential I want. I'm going to put that to volts. And we're going to do a 0.1. What am I talking about? 1. Precision integer. Save. So that's our voltage for our modulation unit. Okay, so that's that done. Let's just link these up because we can. Link mark. Link from out into there. 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 That's that one, and then we want the ISMA. Link mark. Link from out into there. Link mark. Link from out into there. Oops. Link mark. Link from out into there. These are spares. Link from out into there. Link from out into there. Link mark. Link from out into there. Link mark. Link mark. Link from out into there. Right, my digitals. Link mark. Link from out into there. We put you on pause while I just do the rest of these. Right, what I'm going to do with this as well, these outputs, if we lose the controller completely, network's broken or whatever, I want some of these outputs to be on. And at the moment, it will all control. If I put an enable in there, it will enable. But if I've lost network, I want boiler number pump 1, 2 and 3 to run. And I want these to be, I would say, at least 50%. So we can run them. And I want the modulations of the boilers to be about 50%. and I want that to be 10 volts to just enable all three AHUs if we've got no communication. So we need to go back to our ISMA control library. I normally don't use this library, but we want the Modbus IO, not that one, multi-protocol IO, and we want to go to our settings and our default AO. So there's our 1, 2, 3 and 4. Let's bring them across. Actually it's not online. And our Mac, so where's our Mac one? So that's going to be in another library, and do a local device point folder. I don't do a, that's just a library. So if I lose the controller, then that is not going to do it. Let's just do these first. AO1. So our boiler modulation actions set, because I'm using 0 to 100 there. Action set. No, I think that's going to just be 5 volts. Yeah, it is. Action set 5 volts. So if I lose that, action set 5 volts, lose that, actions set 10 volts. We'll leave them in there. Let's just take out the 10 and 16. We probably could put the set in there. Take out the 10, 16 and put set in there. 10, 16 and put set in there. 10, 16 and put set in there. So they're my default settings if we lose communication to this module. If we lose communication to the Mac 36, i.e. it's powered off, then there's no way we're going to be able to set them anyway. So that's pointless, because there's no power on there. And we can't lose communication because there's no network between the Mac 36 and these modules. So if we lose communication, it is what it is. If we lose communication on the mix 4U, 4A, we can set them to the voltages. So that's that done. Where are we now? What are we going to do now? We are going to do the inputs, won't we? Views, wire sheet, digital input 1. So module 1 I want. So I presume that's module 1 there. It is. New Boolean writable. DI1 is fire alarm. Pin slots. So this is going to be fail safe. So we know that true is going to be healthy, and we know that's going to be fire. And then we want to put an alarm on there. Go to our alarms, and we want a Boolean change of state alarm. Drop that into there, and that's going to be fire. healthy. And that's going to be critical. Should we put history on there as well? So we can check when it's gone off on histories. We can check on the alarms, but I might as well check it on histories as well. Boolean change of value alarm. Parent name, that's going to stay as it is. Actions, set. Let's just put it to healthy for now. And let's change that around. Fire when it's false. Next one, plant room gas safety. Well, I reckon that's going to be also the same as that. Fail safe. Gas safety. Next one is low pressure and high pressure. Now, the uncommon fault. I'm going to do these as not fail safe, so the other way. So duplicate. DI3. We can always change it if it's different on site. Low pressure. Go up to there and change that to healthy. Low pressure. Low pressure. Critical. And we want it to be on that change there. Don't worry, it will all work out once you've saved it all and go back. Low pressure. So low pressure is when it's true. Action set. Healthy. Low pressure and then high pressure. Duplicate. DI4. High. And 5 is common fault. Let's just change that to that will change itself automatically. High pressure, duplicate. DI5 is common fault. Use that for generic. Use that for generic. UV filtration unit fault. Water conditioner 1 fault. Water conditioner 2 fault. That's it for that module. Boiler 1 shunt pump flow. Up there. No flow. Flow. We don't want the change of state alarm. Boiler flow, boiler number 1. Oh. Boiler number 1 fault is the next one. DI2. Boiler fault. Boiler number 1. It should all be okay. Yes, yes, yes. Boiler number 1 run status. Run and stop. And boiler 1 common fault. Common fault, boiler 1. So DI2 was actually the shunt pump, so we better put that pump fault, boiler number 1. Makes a bit more sense now. And then 5, 6, 7 and 8 is exactly the same, but for boiler number 2. Rename 5. Rename 6. Rename 7. Rename 8. That's that one done. And then exactly the same for that one. Duplicate. That's because it's changed there. Yeah, we'll just do that. I'll change it again. Duplicate. Because it's DI1. But that's 3. That's 3. That's 3. And that's 3. put you on pause. Right, the other one now, 5, 6, 7 and 8 is district heating pump 4. Fault, flow, fault, on 5. So let's just take them, duplicate. 5, rename, is DH pump fault. I just want to use a fault that's already there. That's a flow. Rename 5 DH pump 04, and it is a fault. Duplicate 6 is a flow. Rename 6 DH, a flow. DH pump 04. Duplicate, rename 7, rename 8. That's that module finished. So I want block A leak alarm. I want an alarm. Duplicate, DI1, alarm, block A leak alarm. I can still keep it as fault. Leak alarm, block A and B booster fault. Duplicate, DI2, booster fault first, I think. Block A and B. Block A and B, Cat 5 booster fault. Kitchen gas safety activated. I'm trying to keep the wording as short as possible so it fits alright in the history as well, which that will fit in fine, no problem at all. There's no spaces, everything's, if there is a space it's an underscore, no special characters, so it will all look good. CWS tank, low level. I presume I'm going to have to, I spelled safety wrong, haven't I? go in there and change the alarm on that. All of them are critical, I would have thought. There won't be the many maintenance alarms. CWS tank, low level. Next one. Duplicate. DI5. CWS tank. Low level CWS tank. Just go back to that one again on the text. Vault. Safety. And text on that one. Level. Low level. High level. And then tank 2. Rename tank 1. Rename tank 1. Duplicate DI8 tank 2. That's that module done. Let me put you on pause. I think the cat wants feeding. It's looking at me. Right, module 5, AHU1 fault. So what do we take? I'll just take that one for now. Duplicate. Fault. AHU01. Let's just see what the text is in this one. At the top first. Fault, that would do for me. Fault. No changes to be made there. Fault AHU1. The next one is fault AHU2. DI2. Fault AHU2. Fault AHU3. Why do the dogs start barking when I'm actually doing a video? Kitchen supply fan. KSF01 digital input. Airflow status, that's going to be. Right. We have a no flow in there, that will do for me. Duplicate. That's 4. And that's a kitchen extract fan. Kitchen extract fan. Status. to put status at the beginning. The status kitchen extract fan. Kitchen, oops, that wasn't extract, that was supply. The next one's extract. DI5. Extract. Supply extract. Toilet extract fan. Toilet extract fan. Block A bin storage extract fan. Block A bins extract fan. Block A bins. Block B bins. That's that module done. So now the final module, module 6, which we only got the 4 UAs. We've already done the 4 A's outputs. Block A smoke extract fan package control system. And we have a run and we have a fault. Duplicate DI1. Smoke extract fans. Block A. And that one is status. And it's a run or a stop. And the next one is a fault. To fault smoke extract fans. Block A. I think we'll change that to rename VL KA. Status smoke extract fans. Block A. Fault smoke extract fans. Yeah, we've got the same for duplicate for block B. Rename 3 B. Rename 4 B. That's that all done. That's all the inputs done, all the outputs done. ready to do the logic, apart from I've got to put these from the controller into the pins in. So let's start with the Mac 36 link mark, universal input link 2, link mark, link 2, and actually they're going to be faulty sensors because they're not even connected. Let me put you on hold, I think, while I do all these. I'll do these ones and then I'll show you how I do the others in a minute. Alright, I'll just do these. Digital input, link 2, link mark, link 2, link mark, link 2. I need to check my emails and see if I've replied already back. Link mark, link 2. Right, so these modules are going to be quite easy to do. So what we do with them is we pick up the module, the points, and we've got this digital inputs here. I'm just going to link mark that. Link from DI1 into there. Link from DI2 into there. Link from DI3 into there. Link from DI4 into there. Link from DI5 into there. Link from DI6 into the in10. Link from DI7 into there. Link from DI8 into there. That was easy. Let's do one more and then I'll do the rest myself. I'll put you on hold. Link mark. Link from DI1 into there. Link from DI2 into there. Link from DI3 into there. Link from DI4 into there. Link from DI5 into there. Link from DI6 into there. Link from DI7 into there. Link from DI8 into there. Well, I'll put you on hold and I'll do the others. That's all the 8 eyes done. Just finally this one. Link mark, all digital inputs, so we don't need to use individual ones. We can just go into here, link from UI2 into there, link from UI3 into there, link from UI4 into there. So now we've completed all our I/O. We never need to use this side anymore now. We never need to look at the ISMA I/O. We never need to look at that. That's only when we're on site. So they're all our inputs and they're all our outputs. They're all going somewhere, which is the module. And they're all coming from somewhere, which is the module. So we don't have to worry now about any more. We just need to do the logic now. And that's it. And the graphics, but logic comes before the graphics. So I don't know whether to leave this video here because we've got 43 minutes into the video, or more, sorry. There's 2 parts, so I think it's a long video, this. So I think I might leave this where it is and I'll continue with starting to write the logic. presume it'd be nice for you to see how I write it all. But you can see how I've laid everything out with my inputs and my outputs. We never need to go into that drivers folder again now. I'm going to be doing everything, taking the information from that folder and taking the information and putting the information to that folder. And that's all I'm going to be doing with this logic folder. We'll see how we go on, but I'm going to end this video at this stage. Thank you for watching.